Hello and welcome back to another session in our continued journey of trying to master permutations and combinations. And our today's agenda is going to be practice and exercise specifically on arrangement of letters. So as usual, I suggest that you try out the questions by yourself and then join the discussion. Also, I am assuming that before starting with these practice questions, you are familiar with the basic logic involved in the arrangement of letters or how it differs from arrangement of numbers and arrangement of people. Very simple idea which we'll keep repeating in the process overall, but I'm assuming that basics are in place and now we want to focus on problem solving, because in each of these questions beyond the basic you will see other ideas in play. So I'm assuming the first part is in place and then we can go through this journey. So please try out the questions and then join the discussion. So let's start with question number 27. Very straightforward, very easy, almost exactly like your standard logic learning question. In how many ways can the letters of the word abracadabra be arranged? So first I will count how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my answer will have a 11 factorial in the numerator. In the denominator, and this is what is special about the arrangement of letters are repeating. So I have to take care that I'm not counting the same arrangement twice or multiple number of times, which is the foundation of this logic or the error in the logic involved. Again, you can learn about, in case this is unfamiliar to you, why this is going to happen, you can learn in the basic session. So let me think of the A's. I have 1, 2, 3, 4, 5. So A is repeating 5 times. I should divide this 11 factorial by a 5 factorial. Is there anything else repeating? There is a R and there is another R. So I should divide this by a 2 factorial. Any other letter repeating? I have a B, I have a B also appearing 2 times. So another 2 factorial. Any other repeating scenarios? There is a D but it is not repeating anywhere. There is a C but not repeating anywhere. So my final answer is going to be 11 factorial divided by 5 factorial, 2 factorial and 2 factorial. And what is happening? In the numerator, I have the overall number of letters factorial, and in the denominator, I have the number of letters repeating. So A was repeating 5 times, therefore I have a 5 factorial here. B was repeating twice and R was repeating twice, so I have a 2 factorial and 2 factorial because of B and R, and my answer is 11 factorial upon 5 factorial into 2 factorial into 2 factorial, which is option number 4. So absolutely the basic idea. It is only there to stop you in case you don't know why this is happening at all. The rest of the questions are not going to make any sense to you. So stop and try and understand why this is happening or what is the idea behind it in case you don't know it. Let's also do a quick recap of the idea because it is very easy. If there were 3 friends A, B and C, and I told you in how many ways can you organize them into a row, your answer would be 3 factorial. How did it come about? For the first position you have 3 options, for the second position you have 2 options, and for the third position you have 1 option. So 3 into 2 into 1 gives you 3 factorial. So if there were 3 friends or 3 numbers 4, 5 and 6, how many numbers can you form? Same logic will apply. So this was our fundamental idea from rules of counting. We've already played with arrangement of letters, arrangement of friends in a row, etc. And from this story, if I tell you there are 3 letters A, B, C, in how many ways can you organize them in a row? Or how many 3 letter words can you form? The same logic and the same answer, your answer would be 3 factorial. So the arrangement of numbers, arrangement of friends or arrangement of letters, the basic logic is identical, because at least in this scenario all the problems are identical. 3 unique numbers, 3 unique friends or 3 unique letters, in each case your answer is 3 factorial. But if I change the scenario a little bit and I say you have A, B, B, how is this different? Because I don't have 3 unique letters, I have only 2 unique letters, one of them is repeating. So what will happen? Before working with the logic also, let me just work with this manually. I can write ABB or BAB or BBA. sit with this for a minute, see can you come up with any other arrangement, and the answer will be no. You can only create these three scenarios. But if you blindly apply this logic, you will say my answer is 3 factorial, which is 3 into 2 into 1 is equal to 6. So according to this logic, your answer should have been 6, but you can physically see your answer is only 3. Why is that? Because in this 6 you are assuming this is B1 and B2. So you are saying A, B1, B2. You are saying A, B2, B1. These two are different to each other. But are they different to each other? Because there is no B1, B2. So this is also ABB, this is also ABB. That means this scenario is being counted twice in this calculation. To fix it, you divide it by 2 factorial. And this is the underlying logic behind whatever we are doing. So when we had the abracadabra question, we had overall 11 letters. A was repeating 5 times, so we put a 5 factorial. R was coming out 2 times, so I put a 2 factorial. B was coming out twice, so I put a 2 factorial. So summarize it for yourself, the basic logic, because in the very next question, not only you will have the arrangement of letters logic, but whatever we have learned in the previous sessions will also get mixed together. So be very, very clear about why things are happening and you know what is the logic behind it. So if this much is clear, the basic idea is clear, the rest of the journey can go fairly quickly. Especially if you have done all the previous sessions, that means you have played with arrangement of friends and learned whatever logics involved there, played with arrangement of numbers and learned whatever special ideas were involved there, because the same stories will repeat here. For example, in question number 28, in how many ways can the letters of the word Wednesday be arranged? Such that the 3 vowels are at the 2 extremes and the middle of the arrangement. First of all, let me count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 positions to fill out using these letters. Such that the 3 vowels, where are the vowels? This is a vowel, this is a vowel, and this is a vowel. Such that the 3 vowels are at the 2 extremes and the middle of the arrangement. So this E, and A can only take the extreme position, that means this position, and the middle position. So E, and A are supposed to go into these 3 slots. So this is very similar to arrangement of friends where 3 people wanted to sit in 3 specific positions. And what did we do there? Very simply put, whatever the question is asking me to do, I will do. That means I want to look at only at E, and A. I want to arrange them in 3 positions. In how many ways can I do that? 3 factorial if there were 3 friends. But the letters are repeating, so I should divide it by a 2 factorial. The moment I write this down, they are out of the story. They have already been taken care of. They will sit somewhere and they can be arranged in these many scenarios, which is the same as what we looked at in the basic logic. So 3 factorial upon 2 factorial. And now you can look at the rest of the story. You had 9 letters, out of that 3 are gone. So you are left with 6 letters, so 6 factorial. Anything repeating in those letters, there is a D repeating twice, so there should be a 2 factorial definitely. Any other repetition, W is only there once, N is only there once, S is only there once, D we have already thought of, Y is only there once. So this is the only division I have to do, and that's it. I have my answer. So my final answer is going to be 3 factorial upon 2 factorial into 6 factorial upon 2 factorial, which is my option number 1. So it is going to be very, very easy if you know the basic logic involved. And for the first couple of questions, repeat the idea for yourself. In the numerator, I have the total number of letters, and in the denominator, I have the factorial of each repeating letter. So in this case, there was D happening twice, so a simple 2 factorial. This was another story where E was happening twice, so a 2 factorial. So I hope the basic idea is clear, and combine it with whatever you have learned earlier, and the rest of the journey will be as easy as this. So question number 29, in how many ways can the letters of the word mathematics be arranged such that the two M's are together, the two A's are together and the two T's are together? So this question is very similar to something that we have looked at earlier. In fact, let's start with that example. I tell you that there are a total of 5 friends. So there are 5 friends. You want to arrange them in a row in 5 positions. But 2 of them, say A and B, they say they always want to sit together. They always want to sit next to each other. This is the only condition given to you. Because if the question was only this, that there are 5 friends and they want to be seated in 5 positions, your answer straight away would have been 5 factorial. But there is something special happening here. They want to be together. And it's very easy then. Okay, they want to be together. So I will consider them as one person or one unit. So from 5 friends, I remove these 2 friends altogether. So I'll be left with 3 friends and this as one friend. So I have a total of 4 friends. So I will rethink my story as 4 friends. Where did the 4 come from? There were 5 friends. I removed these 2. So I was left with 3 friends. And together these 2 are considered one unit. So 3 and 1 together 4. And in 4th position, so my answer would have been 4 factorial. But even inside the box, now this 4 factorial means this box could be here or here or here or here, 4 different positions, right? But let's say the box is here, A and B are in this position, in the 3rd position, which will become the 3rd and the 4th position. But here also it could be AB or BA. That means first we considered them as one box and looked at the initial arrangement, and then I looked deeper inside the box and I saw, okay, I have to take care of this also. That means multiply this by 2 factorial or a simple 2. So this would be my answer for this story. This is not our agenda. We have looked at this earlier in a lot of detail. I'm just doing it here so that we understand what is the logic involved here. And exactly the same idea. In my question, in this question it says the M's and the A's and the T's have to be together. So M and M have to be together, A and A have to be together, and T have to be together. So count your letters. You had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Out of those 11, remove these 6. So out of 11, 6 are gone. This is just your initial calculation. So you are left with 5 letters. And these 6 will become 3 because each of them will be a box. The M's together will be one box. The A's together will be one box. The T's together will be one box. So 5 plus 3, your overall story, you're now thinking of 8 so far. So your answer should be fairly easy, 8 factorial, right? Now if you look inside the box, the M and the M, there is no extra 2 factorial. Why? Because you cannot arrange the 2 M's in any other way. MM will remain MM, the AA will remain AA, the TT will remain TT. So you don't even need to do anything inside the box, because when you were saying there are 2 friends AB, or even if the letters were different, say if the question said M and A have to be together, so it could be MA or AM. In that case I would multiply by 2. If the friends were different, I would multiply by 2, but these are the same letters, so I don't have to worry about that. So this is taken care of. But in the rest of the letters, so if I am removing the M's and the A's and the T's, is there any other repeating letter? H is not repeating, E is not repeating, I is not repeating, C is not repeating, S is not repeating. So that's it, very easily. My answer is going to be 8 factorial. In case this is challenging, this idea of box, I suggest going back to the video on arrangement of friends in a row and the practice session on that, because this has happened a couple of times there. So this should be familiar if you have followed the order. In case you haven't done it and this is difficult, it's a good idea to go back and revise that key idea. Question number 30 now. In how many ways can the letters of the word entertainer be arranged such that no 2 consonants are together? So let me capture the word first. So So in how many ways the letters of the word entertainer be arranged such that no two consonants are together? Again, we have seen a very similar logic earlier when we said, okay, no two boys can be together. And what did we do in that scenario? So let me quickly recap that problem. Say you have 3 girls and 3 boys. They want to be arranged in a row such that no two boys are together. So what did I do in that scenario? I first thought of the girls. There are 3 girls. So let me arrange them in 3 positions. Very simply put, my answer would be 3 factorial. 3 girls in 3 positions. Now when I put the girls in these 3 positions, they create certain positions. As long as I put the boys in these positions, the boys will always be away from each other because the girl will act like a buffer or a wall between the two, right? So now I already took care of the girls. There were 3 girls and 3 positions, so there were 3 factorial ways of doing it. Now there are 3 boys and 4 positions. So what will I do? So what will be my answer? For the first boy, there will be 4 options. For the second boy, there will be 3 seats left. And for the third boy, there will be 2. And this would be my answer. So 3 factorial into 4 into 3 into 2. Now my core logic, because there are more agenda points to be discussed here, which we have done earlier. But the core logic connected to this question is that if you want to keep boys apart from each other, or as in this question, the consonants should not be together, you need to use the others as a buffer. That means you arrange them first and then see how many new positions are created, and then it becomes a question of putting the boys into these positions, whatever that answer comes out as. So let's try the same logic here. I don't want the consonants to be together. So let me take care of the consonants first. This is a consonant, 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 and this is a consonant. So 1, 2, 3, 4, 5 and 6. So I have 6 consonants. And I have a overall 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I had 11 letters. I have 6 consonants and 5 vowels. Now I want the consonants to be away from each other. That means I should place the vowels first. 5 vowels in 5 positions. They will create new position. This is a new position, new position, new position, new position, new position. And to put these 5 vowels in 5 positions, your answer would be 5 factorial. This is a very straightforward 5 people in 5 unique positions, 5 factorial. And now you have these 6 positions created and you had 6 consonants. So you put them also there and you say 6 factorial. Is that it? Is this my answer? I have to worry about one more thing because we are dealing with letters and there might be some repeating letters also involved. So let me think of the vowels first. There is a E repeating, and it is happening once, twice and one more time. So there should be a 3 factorial. There is a but it is not repeating. There is a I which is not repeating. So the vowel part would be 5 factorial upon 3 factorial. If I think of the consonants, N is repeating twice. So this would be divided by 2 factorial. N is taken care of. R is also happening twice. So another 2 factorial. So R is also taken care of. And T is also happening twice, so another 2 factorial to round off. So my final answer would be 5 factorial upon 3 factorial into 6 factorial divided by 2 factorial into 2 factorial into 2 factorial, or 2 factorial raised to 3 or cube. My answer would be option 3. So once again, the key idea being, now notice that you are combining multiple logics, right? You understood the idea of that. What is the issue in arrangement of letters? The issue is counting backwards. So you're dividing. So this is the idea from the arrangement of letters. But this idea we have learned earlier in arrangement of friends. So as you progress further in the topic, you will see all the separate things that you have learned come together and they have to be applied together. So get comfortable with that idea. Question number 31. How many numbers can be formed using each of the digits 1, 1, 2, 2, 2, 3 and 4? So 1, 1, 2, 2, 2, 3 and 4. How many digits do I have? 1, 2, 3, 4, 5, 6, 7. I want to know how many numbers can be formed using each of the digits. That means whatever number I want to create should use all of these digits. That means whatever number I create is going to be a 7-digit number. So my answer is going to be 7 factorial. But 1 is happening twice, so 2 factorial. 2 is happening 3 times, so 3 factorial. And 3 is not repeating, 4 is not repeating. So and that's it. I have my answer. My answer is going to be 7 factorial divided by 2 factorial into 3 factorial. Now it looks like a arrangement of digits question, but it is not. The logic involved finally for this particular scenario only, that you have these 7 digits and you want to use all of them in the same number, these many numbers can be created. So if you can figure that out quickly, that this is the arrangement of letters question, because the same logic is playing out, this question can be done in no time. So question number 32 now. In how many ways can the letters of the word engineering be arranged such that the relative positions of vowels and consonants do not change? So let me capture the word first. So this is the word, and I have to arrange them or rearrange them in such a way such that the relative positions of vowels and consonants do not change. So let me first look at what the consonants are and what the vowels are. So this is a vowel, 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 vowel. Consonant, 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 consonant. And now the question is saying the relative positions of vowels and consonants do not change. What that means in simple language is that if, for example, at the second position I had a consonant, whatever arrangement I make in the second position, there should be a consonant. There can be a different consonant. You can put a R instead of an N, you can put a G instead of an N, but the second position must be taken by a consonant, and similarly the first position must be taken by a vowel, the third position must be a consonant. So once this language part of the equation is done, once you have understood what the problem is, the solution is very easy. How many vowels? 1, 2, 3, 4, 5. There are 5 vowels to be arranged in 5 positions. So how many ways can you do that? 5 factorial. But we are talking about arrangement of letters. A vowel is a letter. Repetition, E is happening once, twice, thrice. So 3 factorial. I is happening once and twice, so 2 factorial. And this is my calculation for arrangement of vowels in these particular 5 positions. And what about the consonants? I have 1, 2, 3, 4, 5, 6. So 6 factorial. Any repeating consonants? Yes, N is happening once, twice, thrice. So 3 factorial. G is happening once and twice. So 2 factorial. R is happening once. So that's it. So my final answer would be 5 factorial upon 3 factorial into 2 factorial into 6 factorial upon 3 factorial into 2 factorial, which is there in option number 3. In the numerator, I have a 5 factorial and a 6 factorial, and in the denominator, I have a 3 factorial and a 2 factorial squared. So the same thing written in different forms. So again, the question might look difficult. Again, you should know the basic logic, obviously, because without this, that why is the 2 factorial there, why is the 3 factorial there, and the basic fundamental rules of counting, nothing can be done. But once this is done, it becomes a case of understanding what the problem is saying. The relative position should not change. What does it mean? Once you understand it, this was nothing but a very basic, very standard question, right? So question number 32, and my answer would be option 3.